Hey everyone, and welcome back for another deep dive with us. Today we're going to be looking at something that I think is really important. It's something that affects all of us, really. It's the spread of misinformation, and specifically how junk science can have like a real impact on policy and people's lives. So we'll be focusing on the autism and neurodiversity community today. We're going to be taking a look at excerpts from this episode 134, all the complete and utter nonsense that's fit to print.pddf. And yeah, this source material is pretty wild. It's alarming for sure, but it's also really timely. So get ready, because by the end of this deep dive, you'll be able to spot junk science like from a mile away.
It's true what you're saying about misinformation. It is getting more sophisticated. I mean, it used to be just blatant lies, but now we're seeing this kind of like manipulation of scientific language. And they even manipulate the research methods to make these like bogus claims seem credible.
Yeah, you're so right. It's exactly what I was thinking when I was reading through this. This source material actually starts with this like satirical study that really illustrates this point. It was published in this fictional journal, the Journal of Complete and Utter Nonsense. And it makes this like completely outlandish claim linking autism to dihydrogen monoxide.
Dihydrogen monoxide. Oh, yeah, that's a classic. It's a classic example of how they use these scientific terms to mislead people.
Right. And it gets even crazier. They go on to try and connect this dihydrogen monoxide with this enzyme that's found in like all maternal eggs. It's called phospholipase C-zeta, I think. And they say there's like 100% correlation between the two and autism. They even recommend these like DHMO-free birthing environment. I mean, the whole thing is meant to be a joke, but it's like a joke with a serious point.
Yeah, I see what you mean. It is a clever way to show how junk science tries to like mimic the structure of real research. Like they use all this technical jargon, and then they point to these correlations that are technically true, but they don't mean anything. They're completely meaningless in terms of proving causation. Like everyone drinks water, and all mothers have that enzyme. But it doesn't mean that those things cause autism. It's like saying, like, everyone who eats bread will eventually die. Yeah. So bread must be the cause of death.
Okay, yeah, that makes sense. I mean, this is water we're talking about, though. It's so obvious you have to laugh. But then I think about all the people out there who might not know much about scientific research and how easily they could be tricked by this kind of stuff. And it's not funny anymore. It's actually kind of scary.
Yeah, it is scary. I mean, look at the Andrew Wakefield vaccine study. That was the whole thing. They used the same tactics. They manipulated the data. Yeah. Got published in this journal that seemed credible, all just to push their agenda. And we are still feeling the effects of that misinformation today.
It's crazy how much damage those fake studies can do. It makes you think about that whole refrigerator mother theory, where they blamed mothers for their children's autism because they were supposedly too cold and emotionally distant. It's just horrifying to think about all those mothers who felt guilty, blamed for something that was totally out of their control.
Absolutely. It's just a classic example of how junk science gets weaponized to control people and to punish them, especially vulnerable groups. And what's even more worrying is that this isn't just something from the past. This is happening right now. Like all the things that allow this misinformation to spread, they're all still happening. We're seeing this rise in these pay-to-publish journals and predatory publishers who care more about profit than scientific rigor.
So wait, are you saying there are journals out there that will publish anything as long as someone pays them?
Basically, yeah. A lot of these journals don't have proper peer review processes, which is like a huge part of making sure the research is valid. And this is how junk science gets a foothold, because these misleading studies end up looking legit.
So there's like this whole industry built around publishing bad science. That's wild. But why? Who benefits from this?
Well, you know what they say. Controversy sells. And there are certain industries that do really well when there are problems, especially if they can offer a solution. The autism treatment industry is a good example.
Oh, you mean all those therapies and interventions that claim to like cure autism, the really expensive ones?
Exactly. A lot of those interventions don't actually have any scientific backing, but they prey on families who are desperate to help their children.
So you're saying this whole crisis narrative around autism actually benefits certain industries?
You got it.
That's messed up. It's like how the pharmaceutical companies in the lawsuit industry, they kind of benefit from the same thing. This idea that there's a crisis.
Yeah, you're right. It is similar. And unfortunately, they also exploit the legal system. They use junk science in court cases. Yeah. This tactic called fire hosing.
Fire hosing. What's that?
Imagine you're a juror and you're on this really complicated case and the science is really important. But you're just bombarded with all these studies, all this jargon you don't understand, and all these experts contradicting each other. It's basically a tactic to overwhelm everyone with a ton of research. Most of it is dubious. And the goal is to just confuse everyone and create doubt. They're not really trying to prove a point.
So it's like that dihydrogen monoxide study, but on steroids, just flooding the system with so much nonsense that you can't tell what's real anymore.
Exactly. And in a legal setting, this can have huge consequences, especially because juries don't usually have the background to know what's real science, what's not.
Wow, this is heavy stuff. It's like we're drowning in misinformation. How are we supposed to know what to trust?
Yeah, it's tough. But there is hope. There are researchers out there doing good work, like Reeser's solitary forger hypothesis. It offers a totally different way of thinking about autism.
Oh, yeah, I've heard about that. Isn't that the one that says autism might not be a disorder at all?
That's the one. It challenges the traditional view.
That's really interesting. I'm looking forward to learning more about that. We'll definitely dive into that in the next part of our deep dive. So stay tuned, everyone. We'll be right back.
Welcome back. Before the break, we were talking about junk science and how it spreads. So you're probably wondering, what can we do about it? As individuals, I mean, how can we navigate all this information out there? Yeah. And not get swept away by all the misinformation?
Yeah, it's super overwhelming. It feels like everywhere you look, there's a new study or a new headline that says the opposite of the last thing you read. So how are we supposed to know what to believe?
You're right. It is a challenge. But the good news is you don't need a PhD in science to be able to figure it out.
Yeah.
One of the best skills you can develop is critical literacy.
Critical literacy. Okay, so what is that exactly? Is it just about being skeptical of everything you read?
It's more than just being skeptical. It's about really engaging with the information, questioning assumptions, and looking for evidence. You have to remember, that information is rarely neutral. Everyone has biases, even scientists.
So you're saying we shouldn't just trust someone because they have a fancy title or a bunch of letters after their name.
Exactly. Authority can be misleading. You always have to consider the source. Like, what are their motivations? Do they have any conflicts of interest?
That's a good point. I mean, it's easy to believe someone who seems like an expert, but they could have a hidden agenda. So, okay, we've talked about the source. What about the information itself? Are there any red flags we should be watching out for?
Definitely. One of the first things to look at is, where did this information come from? Is it a reputable scientific journal, one that's known for its peer review process?
Right.
Or is it just some random website? Or a publication with a clear bias?
Like those predatory journals we talked about, the ones that will publish anything, if you pay them enough.
Exactly. You got to be careful. With those sources that lack credibility, look for studies that have been published in well-established journals.
Yeah.
And that have gone through peer review. Like that dihydrogen monoxide study. That's a perfect example of why the source is so important. If you saw that published in a real scientific journal, you might actually believe it, even though the claims are ridiculous.
Yeah, that's true. The context really matters. So checking the source is important. What else should we be looking at when we're evaluating scientific claims?
The methodology of the study. That's really important. Like, did they use a large sample size? Was it diverse? Did they control for any confounding variables? Are the statistics appropriate?
I don't even know where to start with that stuff. It sounds like you need to be a scientist to understand all of that.
You don't need to be a scientist.
Yeah.
But you can learn to spot the red flags, like claims that are just too good to be true, or that are based on very little evidence. If a study only had a few participants, that's not very reliable. And remember, correlation does not equal causation. Just because two things are related doesn't mean one caused the other.
Like with the dihydrogen monoxide and autism.
Right.
It's easy to misinterpret correlations,
Yeah.
especially when we're constantly being bombarded with data and statistics.
Absolutely. Data can be very persuasive, but it can also be manipulated. Always ask yourself, who paid for this research? Do they have an agenda? Like, if a drug company funded a study on how effective their new drug is, well, that's a clear conflict of interest.
Right.
Following the money can really help you understand the motivations behind the research.
And speaking of bias, we all have our own biases too. We tend to believe information that confirms what we already think.
That's true. We don't like to be wrong.
So you have to be extra critical of information that reinforces your own beliefs or plays on your fears. Those are the areas where
You're most likely to be tricked.
So it's like we should be most skeptical of the things we already agree with.
Exactly.
That's a tough one, but important. Okay, so we've talked about the source, the methodology, and the funding. What about the conclusions of the study? How can we tell if they're valid?
Look out for overgeneralizations or claims that go beyond the data. Be wary of studies that make big pronouncements based on weak evidence.
So basically, be critical, but don't just dismiss everything.
Right. It's about finding a balance. It's not about assuming that all research is bad or that everyone's trying to lie to you. It's about being informed and thoughtful. Science is a process. It's not a set of absolute truths. And sometimes the most important thing is to admit what we don't know.
That's a good point. It's easy to get caught up in looking for answers, but uncertainty is part of science.
Absolutely.
This is all so helpful, but it makes me wonder, if critical literacy is this important, shouldn't we be doing more to teach people about science in general? I mean, not everyone has the time to scrutinize every study they come across.
I agree. We need to do a better job of giving people the tools to understand science. We need better science education, more accessible research, and media literacy.
Yeah, the media plays a huge role in this. There's this constant stream of headlines and news stories, and so many of them oversimplify or sensationalize the findings.
That's true. The media has a responsibility to report on science accurately, but they also want clicks and views. And let's be honest, a nuanced and careful explanation of a study doesn't always get people's attention.
So how can we be smarter media consumers? What can we do to avoid being misled?
Don't trust headlines that make big claims. Look for news sources that use credible evidence and they give you context. And remember, one study rarely gives you all the answers. Science is a process, and the findings often need to be replicated before we can be sure about them.
This all feels really relevant to the whole issue of autism and neurodiversity. I mean, we've seen how junk science can be used to push harmful narratives, and then those narratives are then amplified by the media.
It's a big problem. When misinformation spreads, it makes people distrust real science, and it can have a real impact on people's lives. We need to be careful about what information we consume and what we share.
So it's not just about protecting ourselves. It's about being responsible and advocating for good information.
Yeah.
This has been a really eye-opening conversation. It connects so well with Reeser's solitary forager hypothesis, which offers a totally different way of looking at autism. You ready to dive into that?
Absolutely. Let's explore how this hypothesis challenges the traditional view.
Okay.
And opens up new ways of understanding neurodiversity.
All right, so welcome back for the last part of our deep dive today. We've been talking about all this junk science out there and how it's impacting the autism and neurodiversity community. And you've learned some tips on how to spot misinformation. But now I kind of want to talk about solutions. Like, if we really want to create a world where neurodiversity is valued and respected, where do we even start?
Well, that is the big question, isn't it? It can feel pretty overwhelming. When you think about all the systems in place, that just make things harder for neurodivergent people. But I think one really important place to start is by supporting research that affirms neurodiversity.
Okay, that sounds good, but what does that even mean? Like, what does neurodiversity-affirming research look like?
It's about a change in perspective. Instead of thinking of autism as a disorder, something that needs to be cured or fixed, we need to see it as a natural variation in how humans think. It's like a different operating system, not a broken one. So that means we need to move away from research that's just focused on what causes autism and how to treat it. We need to do research that explores the strengths of autistic people and the challenges they face. We need to understand their perspective and develop supports and accommodations that help them thrive.
So instead of asking, what's wrong with you, we should be asking, how can we help you be your best self?
Exactly. And this means collaborating. We need to involve autistic people in the research. We need to listen to their experiences and value what they have to say. They're the experts on their own lives.
Right, of course. But how do we make sure that autistic voices are really being heard, especially in a field that's been dominated by non-autistic researchers?
It's a good question. We need to create more opportunities for autistic researchers to lead and participate in studies. And research funding needs to prioritize projects that are led by and benefit the autistic community.
So give them a seat at the table where the decisions are being made. I like that. But how do we convince the people with the money to fund this kind of research?
It takes a lot of effort.
Yeah.
We need to advocate for policies that prioritize research that's focused on the needs of autistic people. We need to raise awareness and educate policymakers. And we can support organizations that are already doing this work.
So we need to come at it from all sides. Individual advocacy, community organizing, policy changes.
Exactly. It's a system-wide issue. And it's not just about research. It's about changing society as a whole, creating a world that's more accepting, of neurodiversity. We have to challenge the stigma and discrimination that autistic people face and create environments where their strengths are recognized and valued.
Right, it's not just about the science, it's about real people's lives. So what can we actually do to make this happen?
It starts with education. We need to learn about autism and neurodiversity and teach others. We need to challenge those harmful stereotypes that lead to misunderstanding and prejudice. We need a culture of empathy and acceptance where being different is celebrated, not something to be afraid of.
And we need to make sure that autistic people have the support they need.
Absolutely.
Yeah.
That means access to healthcare, education, job opportunities, and we need to design environments that are sensory friendly and accommodate different ways of communicating.
So we need to stop thinking that there's only one right way to be.
Exactly. We need to be flexible and adapt to the needs of all individuals. Imagine a world where everyone feels welcome, respected, and empowered to be themselves. That's what we should be working towards.
That's a beautiful vision, but it feels like a huge task. It's easy to get overwhelmed.
I know, but you can start small. Educate yourself, talk to your friends and family, support organizations that are fighting for neurodiversity. Every little bit helps.
It's like a ripple effect. Our actions spread outwards and create change. So this fight for neurodiversity, it's not just about autistic people. It's about all of us. It's about creating a better world for everyone.
I couldn't agree more.
Thank you so much for being here today. This has been an amazing conversation.
It was my pleasure. Remember, knowledge is power. And when we use that knowledge to fight for justice and inclusion, we can create a world where everyone can thrive.
And that's a world worth fighting for.
That's all the time we have for today. Thanks for joining us for another deep dive. Stay curious, stay informed, and we'll see you next time.